Let's talk about basic Gen AI implementation concept called RAG, Retrieval-Augmented Generation. I'll try to explain the most basic and most common language as possible so that you all can understand. Retrieval Augmented Generation. So from these words we know it is generating something, it in the sense LLM, from what it is retrieved. So as I explain the concept, it will be more clear. But for now, there is something we are fetching, and we are generating a meaningful content from that. That's why it's augmented generation. Okay, so let's go to the basic flow. You've seen many images, a flowchart, but I'll strip it down. There are majorly three flows, though you can tell two, but I would like to split into three. One is input. So here we have a document to input, such as PDF, Word, Excel, etc. As I'll tell PDF. So you have this. Now this needs to be, we need to extract text from it. Text extraction. Once this text is extracted, we have this text. We need to chunk. Why chunk? Or what is chunk? Chunk is that is the PDF. It has many pages. In that, if you take one page and then you divide it into multiple paragraphs, or let's just say it as you split into two paragraphs, but that sentence you can split even more. So the splitting of these whole page into multiple paragraphs of your required length is called chunk. If you take whole PDF, then splitting it into multiple pages, and then in that each page splitting into multiple paragraphs. So now we have chunk. So each chunk needs to be embedded and indexed. So we embed, and then it is put into a vector database. So this is called indexing of documents. So this is the final step. What is vector database, or what is a vector? Vector is a numerical representation of a string which has meaning. You convert a string that is text into numbers so that that meaning is captured in that. We embed that in form of vector, and vector has a direction. So in basic terms, if you convert one word into vector, for example, similar words like king and queen, they not let's not take king and queen. Let's take much similar. For example, what example can we take? Trees and wood. So the tree and wood. So if you see two words, they are different, but they are similar. Wood is from tree. Maybe there could be some better example. So, but the vectors for these two words are in same direction. And why is that important? I'll tell you in the next step. Now input is done. Once your PDF is in the database, the task of input is done. Next task is retrieval. So retrieval is not, as the name tells, you are retrieving the information. But what matters most? How you are retrieving the information and what information you are retrieving. So first, the you on what why do on which you want to retrieve. So for that you would need a query. Like usually the RAG is built for a Q&A kind of a chatbot, question answer. So we'll have a question from the user. We'll call that as query. So this query is a piece of text, and you already embedded a chunk indexed multiple pieces of text, and this query needs to also be embedded. Once this is embedded, now we have vectors. So earlier we have vector for indexed chunks. Now we have vector for the retriever. So these two vectors can be compared. It's called semantic comparison or semantic search. So what happens in semantic search? Semantic is nothing but meaning. So we don't search based on keyword similarity. Not we in the sense the vectors search based on the semantic meaning of the sentences. So since this query is converted to vector and we already have few chunks which are in vectors in the DB. So now why we need in vector format? The main reason is we are doing basic similarity check is cosine similarity. So the if you keep two vectors, what is the angle between those vectors? For example, your one of your chunk is in this way and your query is in this direction, but you have another chunk that is in this direction. Okay, so the angle between this, I'll call it as theta 1, and the angle between this theta 2. So theta 1, the angle or the difference is less than theta 2. So that means this is most similar. So this chunk is more similar to this query. Then it makes sense. For example, if you're asking really regarding some topic, let's just some regarding a car, and if the car information is present in this chunk, this is considered more relevant. This might have some bike information, maybe not car. So this is not relevant. So that's why this semantic search is done. And then the main reason why to do this semantic search is to fetch top chunks. What is based on your query, we either fetch top 5 to 10 chunks. There are multiple parameters or multiple reasons based on selecting the chunks. For now, I'll tell top n chunks. So with top n chunks over there, now you have ingested, you have retrieved. Now generation is still pending, right? This is still pending. So for that, in order to generate, we need to pass we need to basically give a prompt to the LLM. So that prompt will contain first at the basic level, it will contain their instructions will come when you advance your application, but at the basic level you will pass the content or chunks, that is the content, the chunks plus a query to the LLM, and then that will generate. So this is the basic flow of the RAG. Now why do we need RAGs? I mean, initially when it was started, GPT-4 was not there, GPT 3.5, and the context size was less. But even now, we have models that can take large context. But why do we still need RAG? First one, to reduce the context, minimize the context. Why should we minimize? We've seen examples giving the one PDF and then model is answering anything from that. But that is real time. You add a PDF in the UI, you ask a question, you get the response. But if you go to an organization, they don't have one or two, they have thousands of documents, and you cannot, maybe even though you build it, doesn't make sense. If your response is from one particular page, why do we need to give such whole huge context? And it will consume tokens. Coming to next point, token consumption will increase. So what happens if token consumption increases? Then the third point, cost will increase. Cost is one thing. Then with so much of knowledge at LM disposal, it is possible that it may not generate the accurate response. I'm not just talking about one PDF. There's a lot of, let's just say I give some 10 PDFs together. If we give the required documents and ask it to generate, the response will be much better than giving the whole document. So increased response uh, relatedness. So these are the main reasons why we need a RAG. Gen AI is majorly popular in most of the production use cases, starting with RAG. RAG is the basic implementation. And for your journey to get into Gen AI and learn the concepts, RAG is fundamental. This will help you understand how prompt work, how tokens work, how to deal with LLMs. So getting started with RAG is what I suggest. Hopefully, I've explained all at least the basic concepts. The complex concepts I'll explain in my future topics. But for now, if you have any doubts, let me know in the comments.